Hi everyone, today we are going to discuss the concept of least common multiple, or what is usually referred to as LCM, and also highest common factor, or what is usually referred to as HCF. And then afterwards we're going to solve an O-level E-Math question. Okay, let's begin. What is the least common multiple LCM of 10, 3, and 15? Okay, there are two ways to solve an LCM question. First of all is to think about all the multiples of 10, 3, and 15, and then find the smallest common multiple of these numbers. So let's do that, okay? Let's list down the common multiples of 10 using gray. What do we have? 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 40, 10.5 is 50, 10 times 6 is 60, and so on, right? How about 3? 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 15, blah blah blah. And then of course we have 3 times 10, 30, blah blah blah. And then afterwards we also have 3 times 20, which is 60, and so on, right? How about 15? 15, we have 15 times 1, 15, 15 times 2, 30, 45, 60, and so on. Alright? So the question asks what is the least common multiple, right? And we see here how many common multiples are there, what we have on the screen. Of course, if you list it longer, you will realize there are many more common multiples of 10, 3, and 15. But just for the sake of simplicity and time, we'll just look at this, what we have on the screen, and we see that actually 30, it's a common multiple, right? 30 is in 10, 3, and 15. What else? 60, it's also a common multiple, right? So we see there is 30 and there is also 60. So maybe let me use a different color for 60 so that it's easier for us to see. We use blue, okay? Alright. And then of course, if you, like I said earlier, if you list it longer, the multiples of 10, 3, and 15, you realize that there are actually many more common multiples among these three numbers. And looking at the screen right now, the question asks what is the least common multiple, right? So that means we are only interested in the smallest common multiple, and from the screen it's obvious, right, that the smallest common multiple is in red, which is 30. This is the answer, right? Okay, so this is the first method. So what is the second method? The second method is to use prime factorization. Okay, if you refer to my other video on prime factors, you also learn more about what is the meaning of prime numbers and so on. Okay, for this one, let's just list. Okay, what is the prime factorization of 10? Okay, 10. What is the prime factor that is divisible into 10 without a remainder? 2 is divisible into 10 when we get 5, right? Any other prime factor that is divisible into 5? No, right? So that's it. How about 3? Okay, let's use red for this. How about 3? 3, any prime factor is divisible into 3? No, no prime factor, right? Only it's by 1 in itself, right? So let's just leave it as it is, and then let's use blue. And how about 15? Any prime factor that's divisible into 15 without any remainder? 3, right? And we got 5. Any other? No, that's it, right? And from here we can see, okay, so what is the least common multiple of 10, 3, and 15? So in order for the answer to be divisible into each of these numbers without any remainder, it has to contain the prime factor of 10, the prime factor of 3, and as well as the prime factor of 15, right? So let's see, and let's write down the answer immediately using green. The LCM of 10, 3, and 15, it's equal to Okay, we want a 2 over there, right? And we also want a 5 inside. In this way, if we have 2 and 5, then 10 is divisible into the answer, right? And we also want to have 3, right? In that way, 3 will be divisible into the answer. And we also want to have over here in the prime factor of 15, we have 3, which we already have in the answer, right? The prime factor 3 over here. Let me see. So there is no need to add another 3 into it, because anyway we want the least, right? If we add another 3 into it, then it won't be the least. Okay, and so what do we want? We want 5, because but 5 is already inside the this LCM. It's already listed over here, right? So we don't want to put another 5. If we put another 5, then again it won't be the least, right? Okay, so this is enough. 2 times 5 times 3. So the answer will be 30. So this is the least common multiple of 10, 3, 15 using the prime factorization method. And let's see. Let's check against our first answer. Okay. Oh yeah, it's also the same. It's 30, right? So hopefully you see how these two methods make sense. Because if you see, you watch again the video, you realize that actually the second method is faster. Especially if you're trying to find LCM for really complex numbers, right? If you want to list down all the multiples of a really complex numbers, then perhaps it will take very long for you in order to find the common multiples of all the numbers. Okay, but both of these methods are valid ways to find the least common multiple. Okay, hopefully you understand. Now we'll go on to the next concept, which is the highest common factor. Okay, so let's look at the example over here. What is the highest common factor, or HCF, of 21 and 30? Again, there are two ways to do this. The first is by listing out all the factors of 21 and 30. Okay, so let's list down, right? 21. Okay, 1 times 21 is 21, right? What other factor, what other number? 3 times what is equal to 21? 3 times 7, right? So is there any other number? 4, 5, 6? No, nothing else, right? It's just 1, 3, 7, and 21. These are the factors. Let's look at 30, okay? 30, we know 1 and 30, 1 times 30 is 30, right? So both 1 and 30 are factors. And then we have 2 as well. 2 times 15 is 30. So 2 and 15 are the factors. We also have 3 and 10, right? 3 times 10 equal to 30. Is there any more? 4, 5, yes, 5 and 6, right? Okay, we got no spaces, and we just delete first. And we have 5, right, as a factor. 5 times 6 equal to 30, right? And then we have, just now we wrote 10, we wrote 15, and we also wrote 30. So over here there are more factors of 30. And let's check, what is the highest common factor? We know that 1 is a factor, but is there any other number? Oh, there is 3 as well, right? Is there any other numbers? No other factors. So 3 is the highest common factor, right? Of course, it's higher than 1. So what is the answer? This is equal to 3. There is another method in order to solve this problem, and that method is again prime factorization. So you have guessed by now, it should be a faster method, right? Prime factorization. So 21, what is the prime factor that is divisible into 21? 3, right? Times 7. Alright, what about 30? 30 we have 2, we get 15. Another prime factor will be 3, and we get 5, right? So from here we can see, there is only one prime factor that is divisible into, there is only one prime factor of the 21 and 30 that is common, which is 3, right? So the answer again is 3. So for this first and second method, you see that the answer is the same, 3. Now let's look at another problem for HCF, 105 and 30. And this time around, let's just use the second methods, okay, to solve this problem. So 105, right? 105, if we divide it, what is prime factor that's divisible into 1 or 5 without any remainder. Three, right? You get 35. Is there any other prime factor that is divisible into 35? Yes, of course, 5, right? And you get 7. That's it? Yes. How about 30? 30 prime factor is 2, you get 15. How about 3? You get 5, right? Okay, now you see over here, interestingly, there are um, two common prime factors, 3, and you also have 5, right? But the question asks for the highest common factor. So highest, obviously 5, right? 5 is higher than 3. So the answer over here for the HCF is 5. Do you see the concept now? Okay, hopefully you see. And as you can see, I'm sure you also know that the second method is faster as compared to, listing down all the factors of 105 and 30. Okay? Okay, now let's look at an O-level question. This is from year 2011, paper 1, question 7. Okay, the question says when written as the product of the prime factors, P, Q, R, and list all the prime factors. And part 1 says find the value of the cube root of P. Okay, the cube root of P, basically P 1 over 3, it's equal to 2 power of 3, and just 1 power of 3, multiply by 3 power of 6, and then multiply by 1 power of 3. This is what it means to have a cube, right? So 2, you get power of 1, multiply by 3 power of 2, right? What do you get? 9 times 2, 18, right? Because this is 9, right? This is of course just 2. 2 power of 1 is 2, 3 power of 2 is 9. So 9 times 2 is equal to 8. So let's look at part B over here. What is the LCM of P, Q, and R? Giving your answer as the product of its prime factors. Okay, so the question has already given us the prime factors, as you can see over here, as P, Q, and R represented in prime factors. And so, what we need now is just to list down the LCM. So first of all, we have in the first column 2 power of 3, 2, and 2 squared. So what is the factor that you need to put inside the LCM in order for the LCM to be divisible by P, Q, and R? You need 2 power of cube, right? Because this 2 power of cube will be divisible by P, Q, and R. If you put only 2 power of 1 or 2 power of 2, then it will not be divisible by P, right? So you need 2 power of cube inside. What the second column we look at is 3 power of 6, 3 power of 2, and 3 power of 1. So what do you put inside the LCM? 3 power of 6, right? Because 3 power of 6 will be divisible into the P, Q, and R, correct? Do you see? The 3 power of 6 is divisible into over here, obviously, 3 power of 6 divided by 3 power of 6, and also divisible by 3 power of 2. Yes, right? 3 power of 6 divided by 3 power of 2, you get 3 power of 4, right? And then it is also obviously divisible by 3. So that is why we put 3 power of 6. Anything lesser, so for example, if you put 3 power of square, it will not be divisible by 3 power of 6, right? Okay, how about 5? Do we put 5 into the equation, into the LCM? Yes, right? When you put 5 in, it is divisible by Q, right? What else? Do you need to put 7? Yes, so that it is divisible by R, right? Otherwise, if you do not have 7 inside your LCM, it will not be divisible by R. So this will be the answer. 2 power of 3 multiplied by 3 power of 6 multiplied by 5 multiplied by 7. Okay, so let's look at part C right now. Part C says the greatest number that will divide P, Q, and R exactly. Okay, so over here, let's look at the first column again. Now they're asking for HCF, right? And we have 2 power of 3, 2, and 2 squared. And we also have 3 power of 6, 3 squared, and 3. And we have 5 and 7. So from here you can see, right? Okay, we know that the common factors, okay, maybe I'll just use green, the common factors. Common factors, you will realize it's 2, right? 2 is a common factor. As you can see over here in the first column, it is not 2 square because 2 square is not contained in Q, right? So that's why it's not a common factor. How about 3 over here? If we look at the second column, right, we realize that actually 3, it's also a common factor, correct? It's not 3 square. R is only 3 power of 1. It's also not 3 power of 6 because it's only contained in P but not in Q and R. Alright, how about 5? Obviously 5 is not a common factor because it's only in Q. 7 is also not a common factor because it's only contained in R but not in P and Q. So the question asks for what is the greatest number that will divide P, Q and R exactly. And you see over here the greatest number is 3, right? 3 is higher than 2. So therefore the answer is 3.